to tell you the truth. But shaving just takes time in the morning. So what do I plan to talk about in this session? We're going to look at an overview of some key metrics, then we'll take a closer look. And then importantly, we're going to jump into some traffic grouping concepts. And that's going to lead us into what I call the mother lode of value, which is aligning an application architecture to the traffic groups that we create. And I'm going to ask for somebody. I'm supposed to go 30 minutes, and then we have 15 minutes for Q&A, but feel free to answer questions throughout. In fact, I'll be asking questions. If you have an opportunity to participate and reply back in with a answer quickly, that would be great. Otherwise, I'll answer it, and then we'll move on, because there is a lot of material to cover. But do feel, oh, wait a minute, I guess they can't jump in because everybody's muted, right? Patrick, Paul?
Yeah, that's right. Just real quick, some housekeeping on the questions. Please type the questions in the chat if you have anything for John or really any of the presenters as we go on. Today, we'll try to get to those at the end of everybody's presentations. And if you want to speak at the end of the conference, just put in the chat, hey, please unmute me. We had to mute everybody just so there wasn't any background noise, but just feel free to do it over chat and we'll take care of you.
All right, yep. So I guess I will be answering the questions that I asked at the same time. So, which is fine, no problem. All right, so we're going to jump into this concept of key metrics, and we're going to first kind of organize them into three general categories around availability, performance, and general health. So we'll zoom into each one of those one at a time. Before we start though, what would make, I mean, we have a lot of metrics. The good news is we have a lot of metrics. I don't want to say the bad news, but the challenge is which ones are the most appropriate to use? When would I use which ones, and in which use cases, which alerting, et cetera. So it's useful to think about, hey, there's some metrics that I want that are more important than others, and why are they more important? And this is a list of some ideas around what might make a metric more important. So one is if it gives you early warning through proactive alerting to a degrading situation, or availability is compromised, or a health issue, or it's valuable for triage and troubleshooting if it helps you get to a root cause quicker, like identifying which tier of the application has the issue and then drilling down into that particular tier. If it's useful for trending, for capacity, utilization, other kinds of trending reports, or if it's valuable to feed it into SLAs and key performance indicators for any sort of management level reporting. So a lot of metrics fit in this category. We're going to focus on some stellar ones, some key metrics. So let's start with availability. And I've approached this deck kind of thinking about from an AppResponse perspective. Some of this could also apply to NetProfiler as well. But it's generally those two products that these would apply. Not everything here will fit into a NetProfiler model, but certainly AppResponse primarily. So in terms of availability, you should be thinking about connection requests, because that's a measure of demand on the particular host that's serving out a port. And then along with that is how many of those connections are unsuccessful, so connections failed. So request is a demand indicator, failed is a health indicator, and setup time is another health indicator, indicating that, hey, if I'm continually trending up in terms of how long setup time takes for a particular service, then there's definitely something that needs attention. Then we've got server response time and page response time, which I think you could reasonably argue, yeah, those are probably more like performance than availability. But as you'll see in a minute, slow is the new down. So when things are actually too slow, people may abandon the site, or they might just decide, you know what, I'm just not going to waste my time on it. It's too slow. I'll come back later. So it becomes an availability issue. And then HTTP errors or return codes around any of the 500 series. And throughput and turns can also be a valuable metric looking at it over time, because if you see throughput go down when you expect it to go up, then you've got an availability issue. Something's not healthy in the ecosystem. Same thing with turns. If the turn rate has gone down, maybe there's clients that are no longer able to reach the server. And what we're seeing is a decrease in the number of client requests and therefore throughput. So availability and performance degradation. So now we're going to look at some network health indicators like retransmissions, percent packet loss, round trip time. If we see latency varying, especially if it's heading up, that's going to be a performance degrading condition. All of these are good early warnings to issues with the IT service that we're monitoring. Connection setup time could indicate, as it goes up, it could indicate problems with server busy or virtualization is oversubscribed, things like that. Again, turns and turn rate, server response time. I added user response time here. I didn't put it on the other one, on the other page, but user response time I put here because it really gives you that aggregate measure of not only the server response time, but also how long does it take to move the data across the network, the request payload, as well as the response payload, and then page response time. So 7 good indicators around performance. And then I just grabbed 2 around general health. So TCP resets, and I put with caveats there because, like, if we're looking at HTTP traffic, it's pretty common to see TCP resets all over the place. But if we're seeing TCP resets on a database server, that's probably not a good thing. And that would be an indicator that we need to look into that pronto. HTTP, it's pretty normal. Not much we can do about that. But for other services, it could be important. And then HTTP, the 304s in particular, 301 through, I think it's 304, the one that says you already have your object in the cache, like the client browser says, hey, I've got this thing in my cache, can I use it? So it sends a message up to the server. The server says, yeah, go ahead and use what you've got, it's good. From a caching strategy, there's a positive note in that I don't have to transfer the entire object back down, but the fact that I had to ask the question and wait for an answer could definitely slow things down. And the more 304s you have, you definitely want to look at that to say, how could I change the caching strategy so that I don't have any 304s? And then 401s around unauthorized or authorization failure. That's usually followed by another request with a different auth strategy that does work. So if you see a lot of 401s, that could be tuned from an application perspective. And that's why I put it under general health. It'd be nice to clean those up if you can. So 301s, 304s, 401s, good to watch those and to clean them up if possible. So one of the exciting features of a recent release, I don't know if it came out in 11.8 or 11.9, I think it was 11.8. We're now up to 11.11.1, I believe, is our adaptive alerting and AppResponse. And the reason I brought this up is because some of the key metrics that we just talked about are already included for free in the adaptive alerting. And I'm just checking my magic pointer. There we go. So it does work. So I have a zoom on my pointer, which I'd like a lot, but and I'll use it as needed. But you can see in the policies that there's response time, there's traffic anomalies, packet loss, web server errors. So these are all things that take advantage, out of the box, take advantage of the key metrics that we just talked about. So I would encourage you to check to make sure these are on. They are tunable. Out of the box, they might need a little tweaking for your environment, and then see if it gives you some helpful early warning. So this is a combination of the key metrics with some machine learning and a little bit of AI ops mixed in. So we covered at a high level the categories, somewhere around 14 to 16 different metrics. What I want to look at now is making sure we understand how to interpret those metrics, because this is an area where I find some customers have some challenges with interpreting the data correctly and sometimes drawing the wrong conclusion. So let's jump in a little bit. So in looking at the connection related metrics around request failed and setup time, those are measuring the three-way handshake. So any attempt, so as soon as we see a SYN packet, that counts as a new connection request. If we don't see the three-way handshake complete, that counts as a failed connection. And then the entire time required to set up the connection is measured and stored in connection setup time. So I just wanted to give some context to, all right, this is all about the three-way handshake. Was it successful and how long did it take? And here's a time series chart that it's a nice multi-metric time series chart as opposed to a multi-group time series chart, where we're actually overlaying the count of connection requests together with how many of those connections failed. Now this particular traffic group, and I'll use my zoom here, of all traffic, so this is everything that the box can see. And of course, we can tell that there are some connections failed. We're going to learn in a minute here about drilling down and taking advantage of more specific drill downs to get more clarity on which traffic is actually having an issue. But this is a nice way of looking at two metrics overlaid on the same chart, multi-metric, in this case, connection request, connections failed. And as I mentioned, and I don't know if you guys hear this or not, it'll be interesting when we get to Q&A. If you do hear this from stakeholders and other folks within your partner teams around slow is the new down, we certainly hear it a lot. So server response time is a measure, just showing how do we get that measurement? And it has to do with when we see a request heading towards the server versus when we see the first payload packet come back from the server on its way to the client. So we're able to measure that quite nicely, as well as data transfer time with the appliance. And a nice little chart to view server response time. And we're gonna drill down even further. There's a lot of drill down in this presentation, and all of it is important to making sure we're interpreting the data correctly. So we're going to now look at something that I call conversation grouping density, and I kind of made that word up. It's my word. It's not an official Riverbed word. But for me, it means how much is packed into the group that I'm looking at. Like what's under it? Are there drill downs? Is there a bunch of different conversations together? How dense is it? And it's important to be aware of that as you're looking at the data. And then we're going to look at some host grouping design and how that plays with interpreting our metrics. So it all starts with realizing, and this is such a key foundational point, that what you see in AppResponse and ultimately what it may feed into Profiler, what you see in AppResponse is based on every IP conversation that we see that's fed into the appliance. So if you're feeding in hundreds of thousands of conversations and connections, that's what we're going to report on, and we're going to organize that traffic around different groupings, which we'll talk about in just a second. But the key thing to remember is every data point that you look at is based on real-time performance monitoring of every IP conversation that we see on the wire, what's being fed into the appliance. So here's a super simple example. we'll start with something simple and then we'll ratchet up from there. So here we have a single conversation, a single connection from a client talking to a web server. And I'm going to ask a question and then I'm going to answer it. So if we take an average of server response time for the transactions on this one connection, is that data point meaningful to understand performance of that web server and of the request from that specific host? And I would argue the answer is yes, because we're looking at a very discrete set of transactions from a client to a server. And if we were to just kind of make up some numbers and stick them in a spreadsheet like I did here for an example, let's pretend that on that connection, we had 5 different requests. Each request had a certain payload size. Each response had a payload size. And the server response time for each request had a discrete measurement, because that's what we do inside the appliance real time, is we look at every connection and we look at every transaction and we're calculating the response times and all the different metrics real time. And then once a minute, we're storing those in the onboard performance database in the aggregate metric. So here we are in a case where there was 5 requests. We can see each response time discretely, and the average was 494 for the response time. So that's on that one connection. But let's turn it up a notch and look at it in a little bit more detail. So what if there was a group of, and this word is highlighted on purpose, what if there was a group of IP conversations that we aggregated together? In this case, from host A, there's now 4 connections. That browser opened up 4 connections, sent requests over to host B. And my question is, if we take an average of server response time now, for all of these connections, will it still be meaningful? And I would argue, yes, it would. We're going to get to the no case in a minute. But I would argue that yes, it would, because all of these transactions have something in common. They're all coming from the same client. They're all going to the same server. They're all related. They're all part of port 80. So if we were to drill down into all of those 4 connections using our made-up spreadsheet, we would see something that could potentially look like this, where every request on every connection is being measured and monitored and tracked and calculated. And then we're able to take those response times, create averages for each connection, and then take those averages of averages. So all requests are for the same host, same TCP port, therefore potentially it's all the same IT service. Could be different transactions, but at least we know it's the same IT service. So I'm drilling down to make a point about, we're looking at when you are interpreting the metrics, it's so important to keep in mind that we're looking at the aggregates of performance for every single connection that are grouped, and we'll look at those groupings in just a minute in more detail. And we need to pay close attention to what metrics we're looking at and what grouping we're looking at. So let's look at some more on grouping. So at the bottom of this pretty busy chart, notice we start with IP conversation monitoring. Again, real time, every packet, every conversation, every request, how long did it take, how much payload got moved, was there retransmissions, et cetera. I mean, when I think about what the box is doing under the covers, it's pretty amazing. And depending on which model of the box, I don't know what the exact number is, but I think it's, for the bigger boxes, we're in the, hundreds of thousands, if not around 1 million real-time conversations, tracking state and request responses, the whole deal. And then once a minute storing the data. So everything we see in that conversation gets rolled up into conversation groups. Those conversations groups, they get rolled up into all of these other aggregates, the address groups, which get rolled up into host groups. There's the auto-recognized apps, there's the URL apps, there's defined apps, total traffic. And then there's something even new and exciting, which is the high definition TCP conversations, IP conversations, and latest to hit the stage is the SSL TLS based metrics. So whether we're looking at traffic by IP address group or if we're looking at it by application, or if we're looking at it by host group, or we're looking at it by URL. What's important to remember is we're looking at the roll-ups from all of the conversations that participated in that group, which could be based on the port it used, or it could be based on the IP addresses, or in the case of the URL-based apps and the auto-recognized apps, it could be based on the client hello, the SSL client hello handshake. So there's lots of different ways to look at the same traffic, and you're looking at it from different perspectives. And being able to understand what level am I looking at and how do I drill down to get more specific is key to using these metrics successfully. So let's take it a little bit deeper. So now we're in a new situation. I've got 4 connections, host A talking to host B, but now host B has got an FTP service, and an SSH service, an SSL service, and a NetBIOS service, or SMB2. So now the question is, hey, I've got 4 connections. They all roll up as performance data for host B. If I took the average of server response time for all of these connections, will that be meaningful? And this is where we get to the no answer. No, they won't be meaningful because these services have nothing to do with each other. The response time profile for FTP has nothing to do with the response time profile for SMB. So we have to make sure, if we were looking at host B and looking at the metrics at the IP group level, that we learn to drill down into the more specific subgroups to properly interpret the data. However, same connections, different metric. What if I'm looking at network throughput for these same 4 connections? Would that be meaningful? And I would argue that the answer is yes, because we're looking at a totally different measure. We're looking at network load. And network load, it doesn't really matter that much what the port is. The fact that I'm moving traffic between 2 hosts is the network load. So the port actually becomes not that important. What's important is how much data got moved from a network throughput perspective. So why is all this important? Because what I find is many practitioners often make the mistake of mixing performance for unrelated conversations. And then they draw a conclusion and start to chase a hypothesis that's basically a flawed hypothesis. So the more you understand about conversation grouping, and the more you understand about how the metrics are calculated, the better you'll be able to zoom into the most relevant groups and the group drill down. So group drill down is a concept we're going to spend a little time on as well. So let's take a look at another grouping example. So far, we've seen IP connections. So groups of IP connections between 2 hosts. Now we're going to look at just all of the connections from and to a particular IP host. So new example, now we have all conversations to and from host B. And first question, is host B a client or is host B a server? And the answer is, it's both. Right? It's a server acting for host A, serving out services that host A is consuming. And it's a client talking to host C. So it's both a client and a server. How many total connections can we see? I'm counting 8. If we take the average of the server response time for all of these 8 connections, will it be meaningful? And from our last discussion, you learned, no, it would not be meaningful because these connections have not a lot in common. Well, 4 of them have a lot in common, but the other 4 have nothing in common with each other or the other 4. So no, I would say it would not be useful to look at server response time for host B without first drilling down into very specific conversations of interest. However, what about total throughput per second? For all of these connections, would it be meaningful? And I would argue, yes. Total throughput per second would be meaningful. Why? Because it's network traffic. It's all network traffic. It's bytes in, bytes out. Doesn't matter what the port is. So yes, it would be meaningful. Quick drink of tea here. And I think I have about 15 minutes left. I'm going to try to squeeze it. So we don't have, we can't unmute you, unfortunately. We'll hold questions to the end. So now we're going to double click on something called host group drill downs. So each grouping construct has one or more drill downs, lets you get more specific about the exact traffic of interest. So you can go, and there's lots of drill downs. Each top level group has multiple drill downs. You can visually see them. They don't always show up by default on charts, but there's ways you can make it show up. The full group path name, that's important. Full group path name tells you exactly what you're viewing. And I'm going to show you some examples on the next slide. But first we're going to revisit a top level group. And this is such an important term. It even got its own slide. This is a key term, top level group. Some people at Riverbed might call this an anchor group. That was a term we used years ago. It's the same thing, top level group, anchor group. It's the aggregate of all of the conversations rolled up at that group level. So here we are looking at an application group for all HTTP traffic. So this is all conversations from anyone to anyone where TCP port 80 was the destination port. And let me just ask you, if we took all of that, if we took all of the conversations and all of the response time and we averaged them all up and we gave you an average server response time, is that number meaningful? And I hope you would say probably not, because there's way too many different services that are all munged together under that one grouping. However, there's still great value when you drill down. And we're going to see that in a second. So here we are, we're looking at another multi-metric chart with all of the connections from and to this one host, 172.19.0.60. And notice the yellow line is connections failed, the blue line is connection request. So you look at this and you could say, wow, there's a lot of connection failures. I wonder what's going on with that server. Well, you could say, why is there any? That's sometimes what I ask. Why is there any connection failures at all? But you can't ask that question until you drill down a little bit more. So we're going to drill down now and notice that the format for the group name has changed. This is what's called the full path group name. So top level group, our host, we're going to drill down to apps, and we're specifically going to look at HTTP port 80. So all of the conversations on port 80. Now, one of the things to note is we have no failed connections at this point. So that's kind of good, right? We now know, all right, that while there were connections failed for the entire host, for port 80, there wasn't any. Great news, let's move on. Now, if we look at another application that's being served on that server, we see a built-in application called Alt HTTP, which happens to mean any any HTTP traffic that's not on port 80. So this would tend to be your proxy traffic. Maybe it's on 8000 or 8080. This is a great group, by the way, to find out who's not using the ports you think they should use for having HTTP conversations. Alt HTTP. And now you can see, yes, there were some connection failures at 7:05 in the morning for this particular drill down. Otherwise, it was pretty much flat the whole day, which means there's other applications that I didn't display here that are actually having the connection failures. So let's keep going on our topic of grouping and drill down. So we're going to switch now to groups that you're allowed to configure, which we call, and I'm pretty sure most everybody on this call would be familiar with this, We call them host groups. Back in the day, we used to call them business groups. It's the same thing. Now they're called host groups. So what are some of the reasons for grouping hosts? And the answer is because they have something in common that we want to report on. So we could say, well, everybody that's at a particular site, they have the site in common. So let's do site-based grouping, which is actually very powerful because then you can see all the traffic from and to a particular site. However, does it make any sense to look at average server response time for all of the conversations in this group? We don't know what applications they are. We don't know what the servers are. All we know is that they're all based in the same location. So I would argue, no, it's not useful or important or helpful to look at average response time for a site-based group without drilling down further. However, what about throughput? Answer, like we said before, yes, throughput is perfect for this because yes, we do need to know how much traffic and at what rate is traffic going in and out of a particular site. And then we can drill down further and see, well, which hosts are using the most traffic. Same thing with a port-based grouping, port 443 in this case. I just kind of made that one up, SSL. If we were to look at all SSL traffic visible to the appliance and say, what about average response time? Please know it would not be something that would be useful or helpful because there's too many different applications at the top group level. But throughput is perfectly valid because now I know how much 443 traffic I actually have. And if that changes over time, I need to know that, just like number of connections, maybe connection failures, but not a turn-based metric like server response time. So key points, be aware of the traffic drill down level that you are viewing. You should always drill down to the most specific traffic group of interest. And then when you're creating views, dashboards, insights, or favorite tables, whether you're in Portal or in AppResponse, or maybe even creating some dashboards in Portal and possibly in that profiler, be aware of using the most appropriate drill down for those dashboards. Key point. Okay, we're going to now jump into the mother load. What is a mother load? A mother load is a rich source of something. Oh my goodness, reminds me growing up. Yes, a rich source of something. And the rich source of something that we want to talk about is we want to see what happens when you align your host grouping strategy with the architecture of an IT service or application that's really important to you. So some customers call this quote unquote application onboarding, which means I'm going to create certain configurations specific to the architecture of the application. Some call it service enrollment. And when we get to Q&A, if you guys do this practice that I'm about to talk about and you call it something different, let us know during Q&A because I'm curious what you might call it. So let's look at how that might work. So we have a fictitious group here called ERP. There's 3 tiers, a web tier, app tier, database tier, pretty standard. Actually, these days there's 5 tiers, 8 tiers, lots of tiers. Here's what that app looks like conceptually. There's a load balancer in front of the web tier with the virtual IP. There's another load balancer in front of the app tier, and there's a load balancer or a cluster IP in front of the database pool. So this is what our app looks like. And now what we want to do is align our grouping strategy around this architecture. So let's say we've created our host groups, and I want to just talk about them one set at a time, and then we're going to build this out. So how many groups are shown on this screen? Well, there's actually 2 groups. I've got one group for the VIP, even though there's only one IP in that group, one group for the VIP, and one group for the server pool. So there's 2 groups being shown. Standard question, does a measure of average server response time for these groups have any real meaning? And the answer is heck yes. This is one of the most meaningful uses of server response time. when the traffic is very tightly focused on a particular tier of an application. So we talked a little bit about drill downs so far, but I want to do this a little bit more. So automatic subgrouping, you get these for free. You get apps and ports, connected IPs, member IPs, connected groups. So my question for you is, whose traffic is represented by all the connected IPs talking to the group called ERP Web VIP? And the answer is clients. All of the clients are coming and hitting that Web VIP group. So in one place, we can see the aggregate user response time for every single client hitting this ERP application. Very powerful. Let's build out the app tier. Similar, as we saw before, there's a load balancer. Now we've got a group, a host group for ERP App VIP, a host group for ERP App Pool. How many groups do we have now? We have 4. Does a measure of average response time for each of these groups have any real meaning? And the answer is heck yes. Each one is critical to understanding the performance of this particular application. And when you look at each individual group, you're going to see the specific performance profile for that tier of the application. So here's a pop quiz that I will answer. Whose conversations are represented by Web Pool, Connected Group, App VIP? And the answer is all of the connections leaving any server in the Web Pool talking to the App VIP. So in one drill down, we have the complete performance for all traffic between the web tier and the app tier. Super powerful. Database, here it is, 6 groups. Measuring average response time, you probably guessed by now the answer is heck yes, because it's in context of the application. So why do I call it the mother load? Because when you configure your host groups to match the application architecture, you unlock the power of key metrics. And I use the word unlock, maybe that's not the right word, but the problem is if you don't do this, you're not getting the full value of the key metrics. So when you put the traffic in the context of the application architecture, it brings context to not only the individual tier, but the overall application. And therefore, you can actually give meaning back to your business stakeholders. So it's relevant to the business, which is a good thing. If you don't create meaningful groups, you severely limit the value of the key metrics. And this is bad. We don't want that. We want good, not bad. So very quickly, we're just about ready to wrap up here. Server response time from earlier, we're looking at, in this case, we're looking at our favorite demo system, TradeFast DB servers. And this is an aggregate of all connections from all clients coming into TradeFast DB servers. And this is an average of all that response time. But what if we were to now drill down into the database, connected IPs, and then this client? Now we're looking at a very specific client and the response time that that client is getting from the database. So it brings us more context, it brings us more accuracy. This is a multi-group time series chart that I wish I'd had time to redo because it's kind of funky looking. But what you can see down here is lots of drill downs. So we've got our database server connected IPs, and we've got actually 6 different clients. And because we have the ability to drill down, we can actually overlay all 6 clients in one chart because we're looking at a multi-group time series chart. And we can see at a glance, is every client getting the same performance at any given point in time? And the answer is nope, there's some spikes over there on the left. Blue is looking a little different than the others. It gives you great context. The other reason why app onboarding is so powerful is it really sets the stage to help you easily create application maps in Portal. And application maps in Portal are great. They're wonderful. They're fantastic. They're valuable. You get dependencies, you get status, you get, is there an issue with the host? Is there an issue with the flow? All on one screen. And at a glance, you can see from a triage perspective where you may need to do your triaging. Last example, then we're going to wrap up. I had a small engagement with a interesting customer who was didn't actually know they were having proxy issues. All they knew is people would complain at different times of the day. And by the time the complaints came in, got processed by level 1, handed off to level 2, and then finally received by level 3, the problem went away. But by having good host groups, in this case, a host group for this particular proxy, inside interface in one group, outside interface in another group, we're able to see some key network metrics for a full 24-hour period and get an idea of, well, what does normal even look like? Like, we don't even know if this is good or not, but what do we think normal looks like? Well, this we think was a normal day. And then when we went backwards in time to December 4th, it's like, what? No, there's some serious issues here. Look at that. No wonder people were complaining. And oh, by the way, yeah, the problem did go away. So unfortunately, the customer didn't respond in time. They didn't get to root cause because it came and went through logs. Maybe they found some BGP flapping. I'm not really sure. But now that they have this particular view with a host context and a nice set of key metrics, they're able to very quickly determine in the morning when they come in, how was yesterday? Any surprises? Were there any surprises yesterday? So we're going to do questions in a moment. Last wrap up for this session, and I think I'm close to on time. Here's what your takeaways are. Hopefully, qualify and select your key metrics for proactive monitoring. Adopt a grouping strategy that reflects the deployment architecture for your key apps and services. Be aware of the context of what you're looking at. Be aware of grouping density. We didn't have time today to talk about display time resolution and count versus rate-based metrics. Hopefully, we'll do that in our next session coming up if I'm invited back, Paul and Patrick. And then leverage AppResponse and NetProfiler adaptive alerting. Once you create host groups in those tools, adaptive alerting just makes it all happen. It's almost like it's automatic. It's very cool. And then the last thing I have for you is a shameless plug. There's lots of additional resources. I'm just going to be selfish and tell you about my stuff. There's an Art of Troubleshooting webinar on riverbed.com. There's a nice, I think it's a nice way of thinking about performance, building a digital performance center from our user conference. And there's a number of SharkFest sessions that are recorded that you can reach. And I will stop sharing and turn it over to Paul.
Thank you, John. That was
I wasn't on mute that whole time, was I?
I'm sorry?
I wasn't on mute that whole time, was I?
Yes, you were.
Oh my God, not again. Sorry, thank you.
I'm just kidding. Okay, John, thanks so much. So Patrick, do we have questions in the chat that we need to do before we get to Carol?
Yep. So we had one question that I think we answered already, but we'll just restate it for the group. And it's, can you do site-based and app-based grouping simultaneously? And the answer to that, I believe, was yes. Correct me if I'm wrong, Paul.
Yes.
And it looks like we had go ahead. All right. And our second question was, will AppResponse 11 solve RSPAN GRE issue one day when connected to Cisco ACI leaf switches, so you don't need to use Gigamon?
I'm going to let a product guy give that answer.
Yeah, I was going to say that sounds like a product guy answer because there's multiple answers depending on context, so we need to reflect that to product management. Could we get that user so we can get back to them, Patrick?
Yep, we will. Yeah, we will absolutely get back to you one-on-one with that, your SE.
Yeah, we'll take that offline. Okay, anything else, sir?
Let's see. Okay, we got one last question that just came in. I'm not clear on the implication that you can pin down a user session database performance impact, and how are you able to do that?
Perfect question. Couple different answers. If you have the database module, you can break it down by the actual user, literally the user session to the database, and look at various aspects of performance. And there's also some high definition true plot transaction measures for that user for that session. So the database module is always recommended. If you don't have the database module, then with the ASA module, which I didn't really call out, that was on it was on one of the slides. So everything I showed you with the layer 4 metrics is based on having the ASA module on your appliance. And once you create the host group for the database, even if you just look at it from its IP grouping, you can always drill down to the connected IPs. And if there's, you would expect to see every client who's hitting that database in the list of connected IPs. And then you can further drill down into all the metrics for that user and all the connections. And what I didn't have in this deck is a shout out to the high definition capability, because that would also, the new high definition or HD insights for TCP connections are organized by the two IPs, client and server. So you'd be able to further drill down and look at the individual transaction response times. You wouldn't be able to see the SQL name, but you'd be able to see the individual transaction response time for each database request. So it's easy to do. You create the groups, you feed it the traffic, create the groups, and boom, you got it.
Super. Thanks, John. Anything else, Patrick?
Looks like that's it.
Okay.